So in this video, I'm gonna solve more difficult exponential equations. So in the previous one, we already saw how to convert from an exponential equation to a log, right? So we're gonna use this same formula to solve. For example, let's start with this one, okay? 2 to the x plus 2 equals 20. Now, if we use exactly the same conversion, we're gonna see that now the exponent, it's not x anymore, but it's x plus 2. So whatever we have in here, it's gonna go here. So instead of x, we're gonna write x plus 2, and then the base is 2, right? The base is 2, so we're gonna write log 2, and then whatever we have on the other side, it's the y. I'm gonna just write it here, 20. Okay. Last thing to do is, and be careful with that because a lot of students get confused about it. It's just we have to get x by itself, and then we're gonna subtract 2. And this 2, when we subtract 2 both sides, let's write it. Subtract 2 both sides. This 2, it's going. It's not subtracting the 20, but it's subtracting the whole thing, because log base 2 of 20, it's by itself a number. You cannot split it. All this is a number. So when we subtract 2 both sides, what I have is x equal log 20 base 2 minus 2. Again, with a calculator, first we should compute this and then subtract the 2. The modern calculators, they do this without having to specify it. So we can do, let's see, so second, no, not second, it's alpha f2 log base. So you have 2 was 2 is 220. And then minus 2. It has to be outside of the parentheses. Like some students would put it inside. No, it's outside of the parentheses. Minus 2. Here we go. 2.32. Okay, so that's the answer for this problem. 2.32. Okay. Now, what about if we would have to do something like, let's do a more difficult one. What about this one? This one here. It's a lot more difficult. Well, when we have this here, what we have to do is to make sure we can simplify what we have in here. So we have it in this form, like this. So the base, it's by itself, nothing it's multiplying or adding or subtracting. And whatever, all these must go to the other side. So we have this kind of thing. So a basic exponential function. So to do that, the first thing I have to realize is that I have to remove the 2 before I remove the 5, because, well, the negative 5, because the negative 5 is multiplying. So the first thing I'll have to do here is I have to subtract 2 both sides. Okay, that's what I have to do. If I subtract this 2 in here, that means that this 2 will fly to the other side as a negative. So I have to do negative 2 in this side only. So I have negative 5 times 6x plus 2 equals 1 minus 2, which is negative 1. Okay? Next thing I should do, now I go for the 5. So I have to divide both sides by negative 5 in order to get rid of this 5, which is the same thing as if this negative 5 goes dividing to the other side. So what I have is 6 to the x plus 2 equals negative 1 over negative 5. Now when I have 2 negatives dividing, this becomes a positive. Negative over a negative, it's a positive. So that's what I have. I have and let me keep going down here. So So let me keep going down here. So I have 6x plus 2 equals 1/5. Okay. Now we have actually already reached a point where actually we have this formula. So b is 6, the exponent is x plus 2, and y is 1/5, right? So we just apply this formula again. Okay, so what we're gonna have is, instead of x is x plus 2, because now the exponent is x plus 2, equals, now log the base is 6, right? And then 1/5 stands for y. Okay, 1/5. And the last thing to do is just subtract 2 both sides. So what I have is x equals log 6 1/5 minus 2. That's what I have. I need the calculator to do that. Let's do it with a calculator. So I have alpha f2 log base of 6, base 6, sorry, of 1/5. Now this is inside of the parentheses, and then outside of the parentheses I have minus 2. Okay, what I get is negative point, it's 90, right? This is almost 90. Negative 2.9. That's what I get.